Chalo, comes on everyone. Let's start off. So let's start off with this. So there we have a spring and a block released from rest. Find maximum elongation, time period, amplitude, and the maximum speed. Second thing, block is released from height edge. Find maximum compression. Can you also find time period? Just the equation, huh? It's a little lengthy. That would become an advanced question if you ask for time period. Third one, if the force due to a spring is minus k x cube, it's a non-standard spring. Find the ratio of work done to stretch from x0 to 2x0 and 3x0 to 4x0. So you can't use half kx square. Hmm. Try. I'll give you another minute for the first one. Let's see the first one. So when you release it from here, understand one thing is clear: unit is oscillating in SHM, right? This is the natural length, and what is your speed here? V is equal to 0. That means this is your extreme position. The motion is starting from extreme position, and this will be your mean position. What is the mean position? Where the net force is 0, and that will be mg by k. And we know from the mean position, the body will go another amplitude. So this is your amplitude. You're getting it? There's no need to do anything. Directly you can see and tell everything. So this will go somewhere till here. This is your another extreme position. That must be another mg by k. Therefore, maximum elongation is 2 mg by k. You can use conservation of energy and do it, but with SHM it is faster. Amplitude is mg by k. What is maximum speed and what is omega here? We know time period is 2 pi root over m by k. It doesn't matter how you keep the spring. So omega is root over k by m. In SHM, the maximum speed Vmax is a omega. You know, amplitude in omega, dump everything, you get the answer. What else did I ask you? Yeah, you got everything. Clear with that? Try to do in terms of SHM, that's faster. So basically, since you're starting from rest, that should be the extreme position. That is the idea there. Are you clear with that? Same question, can you do this one? I'll just add one more on this. Let's say initially block M is at rest. Then what you did, you took another block of mass 2m and then you attached it. Now can you find the amplitude? Find amplitude, find maximum elongation, find time period, find maximum speed. I can find all that stuff again. Can you do for this? It's a good one. You can think it as a work per energy, you can think it as an SHM. Yeah, but yeah. So previous one I'm releasing from rest. Here it is already at rest. Then you attach the block. Find the amplitude, find maximum speed. I think if you got these two, you get everything else. Max elongation. What else? Time period to theek hai. That's the easy one. Get this one, I'll give you another minute for this. Same story. So the moment you attach here, always think of like this. The moment you attach, your speed is still 0. You cannot suddenly move. This is your natural length. This is your mg by k. Since you're starting here from rest, this must be extreme. In an SHM, you have zero speed at extreme positions. And then as it comes down at 3 mg by k, that's your mean position. This is your mean. So again, remember that length is from natural length is 3 mg by k. That means this must be your amplitude. And we know the block moves one more amplitude on the other side. So if they ask you find the maximum distance it will travel down, 4 mg by k. If they ask you find the maximum elongation, then it is 5 mg by k. What else you need? Maximum speed. So what is omega? Root over k by 3m. The time period bhi aa jayega. So Vmax is equal to amplitude a omega. Are you clear with this kind of questions, everyone? All clear with this? Can you do the second one? A block is released from the top and falls on a spring. Initial height is h. Find the maximum compression and find the time period. Again, the time period will be an advanced question. If it just asks you for maximum compression, that's a very good mains level question. And others, do keep your cams on. Platform is massless, Aditya. Why it'll get stuck? It's not stuck. There's just a spring there, matlab. It doesn't get stuck, it'll fly again. Let's see. So when the block falls here, I'll draw the whole thing again better. So this is the block. This is the platform. This is height h. Then the block comes and hits the platform. Spring is still in natural length. Then the spring starts getting compressed. At this point, the spring of force will be 0, but the block won't stop. The block will eventually stop at maximum compression. This is kx and this is mg. This is your mean position. You won't stop there. You will have maximum speed here. Eventually, you will stop here. This is your x max. So this green line here is your mean position. And this black line here is your extreme position. This is x max. So you can directly do loss in potential energy is equal to gain in kinetic energy. So that is mg h plus x max. All this energy must have gone into the spring because initial velocity is 0, final velocity is 0, half kx max. That's it. This is a pretty good mains level question. One step, you get a quadratic, you get the answer, you're done. The time is a mess. If the moment they ask you a time, it's an advanced question. Here, this thing has total 2 times. But this 2 come and hit here, your time t1 will be root over 2h by g. Now, the second most common mistake what people do, they think you're going from here to here. So this is 1/4 of an oscillation. Time period is t by 4. That's a blunder. It's not 1/4 of an oscillation. Look at this motion here. From the mean position to the extreme position, the motion, right, can be split into 3 parts. I should have had more space, I guess. Right, so this black thing, if you can see here, this thing will split into 3 parts. So from here to here, there is a time interval t2. From here to here, the time interval is t by 4. Is that making sense? This distance here, the green one, is your amplitude. Are you clear with this? The natural length is some intermediate position. Mean position is the mean position there. So there is some, this distance is not t by 4. So if you split the whole motion into 4 parts, 3 parts actually, I think I need to draw a bigger one. It's a pretty good question though. So we have a block of mass m freely falling. This will take 1 time. Then when the block hits here, this is your natural length. This is nothing actually. Then the block gets compressed here. This is your mean position. So this is your x is equal to 0 mean. This is something else. Then the block eventually will stop here. This is your extreme. This is x is equal to plus a. So from here to here, this time is root 2h by g. From here to here, I don't know what is the time. I'll call it t2. From here to here, the time is t by 4. So the total time period will be t1 plus t2 plus t by 4 two times. If I can find t2, my job is done. And how will you find t2? I know this total distance is x max that we already calculated right now. And this distance must be amplitude. And this distance will be a minus x max. And we know for an SHM equation, x is equal to a sine omega t. So your distance, this will be a minus x max is equal to amplitude sine omega t2. There, this will give you t2. 1 by omega sine inverse a minus x max by a. That's the time taken to go from natural length to the mean position. Clear with that? So there'll be actually three parts to this thing. The common mistake, people think natural length is the mean position. Just be careful with that. What about the third one? The spring force is minus kx cube. Find the work done, ratio of work done to go from x naught to 2x naught and 3x naught to 4x naught. A straightforward mains or a CT level question would be, they'll give you a standard spring. Get this, I'll get in a minute. Let's see. We know work done by internal conservative forces is equal to minus delta U. So when you integrate this, you'll get minus kx cube dx integral from 0 to x is minus delta U. So the spring potential energy will be 1 by 4 kx power 4. So there, for this weird spring, the spring energy is 1 by 4 kx power 4. That itself is a question. So you want to work done from x naught to 2x naught? You can just change the limits there. 1 by 4 k 2x naught power 4 minus x naught power 4 by 1 by 4 k 4x naught power minus 3x naught power 4. Divide them and finish it off. There, that's your answer. Clear with this? Let's get these two. No, this thing we already did. Let's get that B1. We have a rod here, mass M, 2m. The total length is 12. It is released from rest. Find the speed at the lowest position. I can even ask the tension in the string. Find the speed of the particles at the lowest position. It's a light rod. So light rod with two particles m and 2m, one at the center and one in the corner, released from the horizontal position. Let's see. The most common mistake. If you got it, then it is great. People think both the particles have same speed. Particles have same omega. That means if this guy is going with v, which is L omega, this guy is going with 2v. Bus, that is the main thing. That's the thing. So if you go for that, then it's a problem. Then what is the loss in potential energy? One thing has fallen L, mgl. The other one has fallen 2mg, 2l. Is equal to gain in kinetic energy, half mv square plus half 2m, 2v whole square. If they ask you to find tension, you can do that. The tension here is T2, the centrifugal force, 2m omega square, 2l. Here the tension is T1, T2, centrifugal force, m omega square l. So there you can find the tensions also. Clear with that? Let's get these two. Power of a vehicle P is equal to T. M is mass. Find the velocity as function of time T, position as function of time T. Particle of mass m is projected at u and theta. Find the power due to gravity at time T. Let's not power, let's plot. Let's say there is a windmill and the wind is blowing. The power generated by the windmill is proportional to V power n. Find n. Proportional to speed of wind whole power x. Find x. Done. Shouldn't take so much time. These are easy ones. So what is power? Power is nothing but force into velocity. But what is force? Mass into acceleration. What is acceleration? dv by dt. Integrate on both sides. This will be mv square by 2 is equal to t square by 2. Make it v is equal to t by root m. This will be dx by dt. Integrate again. Make it x is equal to t square by 2 root m. Done. What is the power? Power is F bar dot V bar. What is the force? Minus mg j cap. What is velocity? U cos theta I cap minus plus u sin theta minus gt j cap. Only the j component will come. So this is minus mg into u sin theta minus gt. It's a straight line. So if you actually try to plot a graph, power versus time, initially power is negative. At the highest point, power becomes 0. It's a straight line with a negative y-intercept. X is equal to 3. How did we get that? So when the wind is blowing, take a thin cross section of dx. So dm will be density, area, and thickness. This is your dm. The small kinetic energy will be half dm, which is rho a dx v square. Power is nothing but kinetic energy per unit time. So that's half rho a dx by dt v square. That will be half rho a v cube. That is assuming all the wind ka power is converted into electricity. That's not true. You will get an efficiency of maybe around 15-18%. Clear with that? That's a cube function for the power there. Let's see one more like this. If I add one more on power, we have a heap of chain. Someone is pulling this chain out of the heap with a force F. Linear density lambda. The speed of the chain is pulled out with constant. This is x, and gravity is present. Heap of chain. So chain is pulled out with a constant speed vertically. Find the power due to the external force and find the heat produced per second. The moment I ask you heat, it becomes an advanced question. If I just ask you find force or find the power, find force or power as function of x, this is still a decent mains level question. Find heat per second. That would be an additional thing. Let's get this. Again, variable mass system and power. What is the catch? Now, in case you don't know this, let me add something for here. Suppose if you have a chain, and if you're just pulling the chain out of the heap, let's say you pull the chain out of the heap with a speed u. If you take a small piece, the dx, the momentum will be dm into v, which is lambda into dx into v. Force will be dp by dt, which is lambda dx by dt into v, which is lambda v square. So this is the force required to pull the chain out of the heap. You can't use F is equal to ma here because the mass is changing. If you just want to pull the chain out of the heap, you have to apply this much force. Now, if you combine all this stuff together, so this part of the chain which is hanging, I'll just remove this. You have your own weight mg, which is lambda xg, and because you want to pull the chain out of the heap, Newton's third law, it will exert a force on you, lambda u square. So the force F will be lambda xg plus lambda u square. This is a variable force. Force is not constant. As time passes, the force is increasing. And what is the power? Force into velocity. That will be lambda xgu plus lambda u cube. So this is the power given by external force. So this external force is supplying this much power. But something interesting happens. If you look at the energy of this chain, you have two things, the potential energy plus kinetic energy. The potential energy, you have to take the center of mass, which is lambda x, this is the mass, g, and x by 2. M, g, h center of mass, plus half mv square, which is lambda x u square. This is your energy per chain. So the power absorbed by the chain or power stored by the chain will be dE by dt. That would be lambda g by 2 x square ka differential plus half lambda u square dx by dt. This comes out to be lambda g, that will be x dx by dt is u plus half lambda u cube. Can you see some difference there? The heat produced per second, the power due to the external force minus power absorbed by the chain. They are not equal. You get a difference of lambda u cube. The external force is giving more energy per second, but for some reason, you're not storing all that energy. Something is becoming heat. The reason actually goes like this. We'll not go too much into this. If the reason is this, the chain which is at rest and this chain which is moving, when this chain suddenly goes and hits the chain, it stops. So it's kind of like inelastic collision, isn't it? The chain starts with some speed, hits the chain which is ahead, and you hit that chain and you both go with the same speed. Think about this. All the links which are going up are going with the same speed. It's kind of like perfectly inelastic collision. Right? So yeah, red line, it will be lambda u cube. That's a u cube. So every time that chain comes out of the heap, it will gain some speed, but when it hits the chain in front of you, you lose energy and the speed becomes constant. So you lose energy there. It's like a in continuous inelastic collisions happening between the chain link. So the chain actually gets hot. So this is the heat produced. Clear with this? There, you can play like that. Then there is one more I wanted to ask. Let's get this thing. We have two balls, m and 2m, e is equal to half. This thing comes with speed u and hits the ball to m. Find the minimum speed if it completes a vertical circle. I hope you remember the results for vertical circle. The minimum speed for a string is root 5gl. For a rod, root 4gl. The difference between tension and the up and the lower is 6 mg. Standard results. Matlab, you should literally remember them. Matlab, CET mein they'll ask. Mains mein also you can expect like questions to there. Abhi bits ka dates bhi aa gaya na. Actually, in a way, it is a good thing. Every year, what happens now? The bits 2, they used to keep it in June 2nd week. Advance used to get over by May 3rd week. People used to get pissed off. And I have seen many people ignoring bits 2 actually. Matlab, they used to get burned out actually. Not your fault. Hota hai. When you write exams from Jan till May, people burn out. But now this is good. May 17 advance will get over. May 24 next week, bits will get over and you're free. So, yeah, May 31st we'll have a farewell though, farewell party, but then you're free. June, July, you'll get 2 months break there. August 1st, college will start. Let's get this thing. Collisions and vertical circular motion. Right, Navya. How to do head-on collision problems? Step 1, choose your final diagram. Step 2, conserve momentum. Step 3, restitution. So after collision, let the velocities be v1 and let this velocity be v2. Conserve momentum. Initial momentum mu is equal to mv1 plus 2mv2. Then write restitution equation. E is equal to v2 minus v1 by u minus 0 is equal to half. We get v2 minus v1 is equal to u by 2. You're not interested in v1 to take v1 and substitute here. This will be v2 minus v1 will be u minus of 2v2 plus is equal to u by 2. We get v2 is equal to u by 2. But we know v2 must be greater than equal to root 5gl if you want to complete the circle. Therefore, u must be greater than equal to 2 times root 5gl. Easy? Let's get this thing. We have a pendulum u is equal to root 4gl. Find the position when the tension becomes 0. I can ask you find h max also. That would be still goes to an advanced level. But if you can just find the tension, that is the main question. Find h max. The second is another standard one. There is a nail at a distance x from the point of suspension. Find x if the pendulum completes a vertical circle. What to do? So at the point when the tension becomes 0, put 4gl, that would be somewhere at this position. Your tension becomes 0. I will take the vertical as an angle theta. So at this position, so this is theta. So this will be mg cos theta. And the centrifugal force will be mv square by L. We get mg cos theta is equal to mv square by L. This height will be L cos theta. Conservation of energy, initial energy half mu square, half mv square plus mg L into 1 plus cos theta. Solve these two. You will get v from here and theta also from here. You'll get some sine theta or cos theta. Once you got this, meaning question got over at that instant, but this is going with V and this is flying with theta. So this thing will not stop. This will actually string becomes loose and flies like a projectile. And this will be a height of V square sine square theta by 2g. If someone asks you to find the H max, that will be L plus L cos theta plus V square sine square theta by 2g. If you guys remember the answer, I think it is 50 by ऐसा कुछ तो आएगा 50 something like that. I don't remember, but 54 by 27 or something. Mg cos theta, mg sin theta, na, that is. No one will balance mg sin theta. Deceleration, no, that's the speed is decreasing. Right? So after that point, the string becomes loose and it flies off like a projectile. Hope you remember this question. Hey, class notes mein, same question. Check kar lene ek bar. What about this guy? This is also there in the class notes. So when this thing comes to the lowest position, your speed should be root 2 gl. And the radius of this circle, the green one, is L minus x. So this must be greater than equal to root 5 gr to complete a circle. So we get 2gl must be greater than equal to 5gl minus x. We get x must be greater than equal to 3l by 5. So the answer will be, it should lie between L and 3l by 5. Another standard question. Clear with that. When the pendulum comes to the lowest position, speed is root 2gl. So this root 2gl must be greater than 5gr, where r is the radius of the circle. By shifting the nail ka position, you're actually messing up the radius of the circle. You're not messing up the speed of the particle though. Is that clear, everyone? Let's get this thing. Center mass of these three shapes. We have a V-shaped rod, length L, 2L. Find the center of mass. Solid cone, solid hemisphere, find the center of mass. Arc, 60 degrees, find the center of mass. You're done? Let's see. Shouldn't take so much time. So the center mass of this rod will be somewhere here, which will be the coordinates. If you see, it will be L cos theta, comma, minus L sin theta. And what will be the mass? 2m. That is a catch. They will have different mass though. And this guy ka coordinates will be L by 2 cos theta and L by 2 sin theta. And this thing mass will be m. So mass is proportional to the length of the rod. So you're done. So x center of mass will be 2ml cos theta, ml by 2 cos theta by 3m. Y center of mass will be 2m minus L sin theta plus ml by 2 sin theta by 3m. What to do with this? For the cone, for a solid cone, the center of mass is at h by 4. Let the mass be m1, the distance is h by 4. Let the mass be m2, and this distance is 3r by 8. So if you don't know your results, you are gone. Therefore, y center of mass will be m1. What is m1? Density into volume 1 by 3 pi r square h. What is m2? Density into 2 by 3 pi r cube. We have a very good discussion on this thing about stability of the shape. You should definitely go and check out the notes. That would be a good advanced question. Find the condition of h by r, if the system is in stable equilibrium. So, and then you solve this. So m1 h by 4, m2 minus 3r by 8 by total mass. And if you solve this now, you'll get if h is equal to root 3r, you'll get y center mass is equal to 0. Should check out the notes for more on that. And what is the center of mass for an arc? Anyone remember the formula? The center of mass ka formula is 2r sine theta by 2 by theta. Theta must be in radians. Substitute there, you'll get the answer. Clear? Let's get these two. The standard one. We have a semicircular pipe. Inside there is a chain at rest. Someone disturbed it and the chain started coming out. Find the speed when the chain comes out. L by 4 of the chain is hanging on the table. Find the work done to put the hanging part back on the table. Let's see. Straightforward. Initially, the center of mass is at 2r by pi. When it becomes a straight line, the center of mass is at the center. The loss in potential energy is equal to gain in kinetic energy. If a chain is hanging, 1/4 is hanging, 1/4 ka center of mass is L by 8 and mass is m by 4. So change in potential energy is the work done. Remember this? That's mgl by 32. Both are standard models. Do you guys remember this question? We have a block M and we have a spring here, K. Initially, this is at rest. Someone is pulling this point A with a constant speed U. So one end of the spring is pulled with a constant speed u. Find max elongation and max speed of block. We have a ring here and we have ball here. Let's say this is M and this is 3M. This is the string of length L. When it becomes vertical, find the tension. That is the right answer. Get the maximum speed. That would be a good one. Again, if I don't tell you anything, it is in the ground frame. नहीं भरोसा. You remember there's a statement I keep saying. If something is moving with constant speed or something is moving with constant acceleration, go and stand on it. So how we do this? If you go and stand on A, so this guy, now see, remember, he's an inertial frame, okay? He's going with a constant speed. So it is an inertial frame only. So you will think the block is going with speed u. So in his frame, he will think I'm a fixed point and the block is just oscillating. So here you'll come to rest. This is your maximum elongation. So half mu square is equal to half kx square. Okay, but now in his frame, the block again will come back. Now in his frame, when the block comes back, it will come back with the same speed u. So velocity of the block in the ground frame is velocity of the block in the frame of A and velocity of A in the ground frame. Now this is clear. Velocity of A is always u I cap. So when the block ka velocity also comes in the same direction, you'll get maximum speed, isn't it? In A ka frame, what is the maximum speed of the block? U, right? But it can be plus u cap to minus ui cap. So this thing can vary between minus ui cap plus ui cap. Therefore, max speed will be 2u in the ground frame. Is that clear, everyone? That's a good one. This whole stuff is with respect to A. So this is what A thinks about the problem. What about this guy? Let's say this is going with V1 and V2. Conservation of momentum, initial momentum is 0, mv1 minus 3 mv2. V1 is equal to 3v2. Loss in potential energy mgl is equal to 3 mgl is equal to half mv1 square plus half 3 mv2 square. Now, when you find the tension here, I think we discussed this last time, the tension T upward, 3 mg downward, the center is moving. So A centripetal will be V relative V2 minus of minus V1 ka square into L. So just be careful about that and then you're fine. So we get tension will be 3 mg plus 3m V1 plus V2 whole square by L. Conservation of momentum, conservation of energy, circular motion, and LM, 4 chapters. Is that clear, everyone? Let me ask you one more. Let's say we got a rod. X is equal to 0, X is equal to L, and let's say lambda is equal to lambda naught X. The string is cut here. Find alpha just after cutting the string. It's not a uniform rod. The rod cut density is changing as lambda naught X. Find the angular velocity of the rod just after cutting. It's a good one. It looks innocent, but it's a nice one. Let's see. What do you think? Manch?
Did well, no?
So you tell me. Exam में whom will you ask? Invigilator को. See, in this question, there are 3 integrations you have to do. First thing, I don't know the mass. So at a distance x, take a small slice dx. So mass will be integral lambda dx. That will be lambda naught x dx from 0 to L. That's lambda naught L square by 2. Next thing, you need to find where is the center of mass. Integral x dm by integral dm. Integrate this. I know the result. It's 2L by 3. Then you have to find I about the hinge, moment of inertia. That is integral dm x square. This is lambda naught x dx x square. That is lambda naught L power 4 by 4. Got it? Now, when you draw the free body diagram, you have to write mg from the center of mass. Therefore, torque about the hinge will be mg 2L by 3 is equal to I about the hinge into alpha. You're getting the problem there? You have to integrate for m, center of mass, and moment of inertia. You have to do 3 integrations. And then what is m? M is lambda naught L square by 2. G 2L by 3. I about hinge is lambda naught L power 4 by 4 is alpha. So there, figure out whatever is the answer. Clear with this. It won't be ml square by 3. That's for a uniform rod, isn't it? Can't we integrate torque by itself? Fine, na, integrate the torque. Still you have to integrate for I though. Moment of inertia, you won't get it. Clear? You can, what Projas is also good actually. You can directly integrate that torque. That also works. All clear with this? Let's get these three. We have a rod lambda is equal to 2x plus 3. It is hinged, meaning there is a support there at x. Find x if the rod remains horizontal. An half disk is hanged from one corner. Find theta in equilibrium. Four plates are kept one on top of another as shown. Find the maximum x. Find the maximum distance the plates can be pushed outside from the table. C ka acha result. I hope you guys remember. You should remember the results for C. You won't have time to derive. You can check out the Centro Mosca notes for the proof though. Done. So what are the catch for the 67? If the rod is remaining horizontal, that means that point must be the center of mass. That is a catch. और कुछ नहीं था. Because if it isn't remaining in equilibrium, the mg must pass through the hinge. So this point was the center of mass. So indirectly, I'm asking you to find the center of mass. Integral x center of mass will be lambda dx, so that is 2x plus 3 dx into x 0 to L by integral 2x plus 3 dx 0 to L. I will leave it to you solve that. What about this thing? If you guys remember, whenever you hang a body, the center of mass has to pass through the center of mass has to be exactly under the point of suspension. Why? Simple reason. If you draw the forces, we have Ny, we have Nx. Since it is in equilibrium, torque about the hinge is zero. Ny ka torque is zero, Nx ka torque is zero, so Mg ka torque has to be zero. So it should lie somewhere on this line. But we also know the center of mass will lie on a bisector here at a distance of 4r by 3 pi for a disk. I hope you remember the result. And this radius is r and this angle is theta. So tan theta is 4 by 3 pi. Easy. So there are two things. The center must lie on the bisector of this, and it should also lie on the vertical line passing through the hinge. What about this thing? This thing, now there is a pretty good result. The first one will be L by 2. L by 2, L by 4, L by 6, L by 8, and if you have L by 10 and so on, it forms a HP. So you can put this thing. So check out the class notes. Center of mass may be proved it. The heading is stability of systems. There we wrote it. Clear with this. Take a break. Come back in 5 minutes. We'll continue from here. Several times. Classes. పెడతాను. Sure, comes on everyone. Let's start off. Let's get this thing. Three shapes. Find the ratio of potential energy. Solid hemisphere, solid cylinder, solid cone. Find the ratio of potential energy. What is the answer? 3 is to 6 is to 1. Check. What is the potential in this system? mg, h center of mass. So first thing mass is rho into 2 by 3 pi r cube. Next one mass is rho into pi r square h. Next is rho into 1 by 3 pi r square h. And you know the center of masses. Let's get the center of mass of these three things. We have a uniform plate y is equal to x cube. Find the center of mass. We have a disk with cavity, solid sphere with cavity. Hope you remember the results. Find the center of mass. We have a square plate where 1/4 is removed. Find the center of mass. Let's see. How to find the center mass of that one. See how to find the element here. At a distance x, take a dx. You get a thin rod. Now for this thin rod, the center of mass will be, this is dx, this is height y. So for this thin rod, the center of mass will be x comma y by 2. So mass of this thin rod dm will be sigma into y into dx, the length into breadth. So for x center of mass, it will be integral. Remember, this is x coordinate of the rod, dm of the rod. That is the meaning of that formula, integral x dm by dm. So that would be x. dm of the rod is sigma y dx. This goes from 0 to 1 by integral sigma y dx. But what is y? Y itself is x cube. Sigma goes off. That would be x power 4 dx. 0 to 1 by integral x cube dx. That will be 1 by 5 and this is 1 by 4. So 4 by 5. Now when you take y center of mass, be careful. It is not y coordinate. It is y of the rod, dm of the rod by integral dm of the rod. The y of the rod is y by 2. This is sigma y dx 0 to 1 by integral sigma y dx 0 to 1. Sigma goes off, that will be half, and y square is x power 6, x power 7. The 1 by 7 by, this is 1 by 4. Then it will be 2 by 7, I guess. Check your calculations. Clear with that. That is how we find center of mass if you give some weird curve like this. Others, keep your cams on. And for disk with a cavity, minus r by 6, disk with a sphere, minus r by 14. Standard results. Check out the notes in case you don't remember them. What about the square plate wala? The square plate is easy. Divide the whole thing into 4 pieces. So this is one center of mass, this is one center of mass, and this is one center of mass. So the side is L, so this coordinate will be L by 4, comma L by 4. This will be 3L by 4, comma L by 4, and this is L by 4, comma 3L by 4. All have same masses, M and M and M. Just finish it off, M1, X1, M2, X2, and you get it. Clear with this. We have 5 questions here. We have a semicircular toy train going with speed u in a circle of radius r. Find the momentum of the train. I can even ask you more questions. Find velocity of center of mass of the train. Find acceleration of center of mass. Momentum of the system with respect to center of mass is how much? Kinetic energy of the system is always equal to kinetic energy of center of mass, true or false. Internal forces cannot change momentum, but it cannot change momentum and energy of the system, true or false. If you have a chain hanging, and if someone pulls the chain with a force of vertically down, what happens to the center of mass? Will it remain there? Will it go down? Will it go up? If you have a block here on a smooth incline and the ground is rough, when the block slides, which way will the center of mass move? 6 questions. Get them. Mostly theoretical. Let's see. Look at this thing. When the toy train is going in a circle, the center of mass, which is 2r by pi, that also goes in a circle of 2r by pi. What will be same for the train and this thing? They'll have same omega. Isn't it? When the train completes one circular motion, even the center mass will complete a circle. So both will have same omega. So momentum of the system is mass into this thing. What is acceleration of center of mass? Omega square r. Momentum of the system with respect to the center of mass is always 0. That's a important statement there. Because if you go and stand on center of mass, you'll think it is always at rest. So momentum will not change. So they can actually frame the question in another way. Linear momentum can be always conserved in the center of mass frame. That is always true. Even if you have external forces on the system, Because the momentum is always zero, linear momentum is always conserved in the center of mass frame. Are you clear with this? When you stand on the center of mass, you think the center of mass is at rest. So in the center of mass frame, there is no momentum to the system. So if there are 1,000 particles going in every random direction, and if you stand on the center of mass, all their momentums cancel out. Kinetic energy of the system is kinetic energy of center of mass plus kinetic energy about center of mass. Hope you remember that is the actual formula. Internal forces cannot change momentum, but they can change kinetic energy. When a bomb explodes, you gain extra energy because of internal forces. Internal forces can do work, so be careful with that. They can't affect the momentum though. What about this thing? When you pull the chain down, aren't you doing positive work? Force is down, displacement is down. So work done by external force must be change in potential energy. That means the center of mass must have gone up. Are you getting the logic there? Now you can't tell from the shape, okay? When I'm pulling down, displacement is also down, work done is positive. So the energy must have increased for the system. But the kinetic energy is zero. Then the only way energy can increase is by increasing gravitational potential energy. That means the center of mass of the system must have gone up. Clear with the argument? Now, when you take the wedge and the block, as the block is pushing down, the friction will act on the left hand side. The system will always move in the direction of net force. That means the center of mass will come down and will go towards left, isn't it? The center of mass of the block and the wedge must be going left and down. Is that making sense? Because the wedge will try to go to the right, the friction will act towards left. Hi, Ishil.
There isn't the normal internal force.
Fine, normal is internal force. Who is talking about that?
No, if we don't consider that internal force, the resultant
Don't
will be
consider.
just the friction.
So
So
that is the
the
reason.
center
Where did I
mass.
say? Where did I say N is external force?
नहीं उसके लिए नहीं मतलब अगर if n is internal, so we are not considering that, right? So
We are
the
not
only
considering.
force the only force acting is the friction. So the center of mass should
No,
move to
there is
left,
a
right?
Arre God, there is N on the ground also. M plus mg is also an external force.
अच्छा, right.
There are vertical forces also, na. Horizontally, there is only friction. Vertical में N ground भी है. Hmm. All clear with this? Can we conserve linear momentum about center of mass? Yeah, that's what I said. You can conserve linear momentum in center of mass frame, even if there are external forces. Pseudo force से कुछ मतलब नहीं है. That is torque you're talking about. If pseudo force is acting on center of mass, then torque about center of mass is zero. You're mixing up two things. If there's a pseudo force acting on center of mass, how does that not? So tell me one thing. Does it in linear motion? Does it matter where the force acts? If there's a force on a system, no matter wherever it is, you can't conserve momentum, right? So done. That's it. You're mixing up things. Then before going ahead, let's do another one. This is another good one. Let's say this is going with you, and let's say this is going with 2u. Find max compression. Find time period. Find amplitude of the blocks. Find energy of oscillation. I hope you guys remember there's something called energy of oscillation, which we did in SHM. Energy of a system is different from energy of oscillation. I can even ask you more questions. Find the maximum or minimum speed of both the blocks. I think that we can figure it out. Let's get these four. Ground is smooth. The first two are pretty good mains level questions. Matlab, you should mug up the result and you'll get them like pretty fast. C and D, you have to do some work. C and D will be this. The whole question becomes a pretty good advanced question. Root 6mk by u. Let's see, I don't remember the answer. Get all four. I'll give you 3-4 minutes and I'll show you the whole thing together. Do you guys remember the result for this? First two questions now have standard results. Mug it up, huh? You will save time in the exam. Half k x max square half mu v relative square. Mu will be m1 m2 by m1 plus m2. In our scenario, it is 2m by 3. V relative is v1 bar minus v2 bar. In our scenario, it is u minus of minus 2u, which is 3u. We did this thing in, again, center of mass, you can check it out. This is half 2m by 3. That mu is the reduced mass and 3u whole square. You'll get the answer. What is time period? 2 pi root over m by k. M ka place mein you have to put mu. You'll get the time period. Yaad aaya? That's it. Use reduced mass, you'll get the answer there. What about C and D? Amplitude and energy of oscillation. You guys remember what is energy of oscillation? This energy of oscillation, this is the component of energy which transfers from potential to kinetic and kinetic to potential. The entire energy of the system does not, oscillate between potential and kinetic. This is the energy of the energy which converts from kinetic energy to potential energy and potential energy to kinetic energy. There is a component which transforms. Think. I'll give a minute or two. D looks scary. If you actually understood what it is, then the answer is pretty straightforward. Let's see. So what is actually happening now? You can see this theoretically. Look at this statement here. The kinetic energy of the system, you can split this into two parts, which is kinetic energy of center of mass plus kinetic energy about center of mass. So if you notice, since velocity of this guy is constant, actually, this will not change. So if you the whole energy is split into two parts, since velocity of center of mass is constant, the kinetic energy of center of mass does not change. That means there is a part of the energy which will not change, and there's a part of the energy which is actually going into kinetic and potential, isn't it? This is your oscillation energy. So this is nothing but half k x max square, isn't it? The maximum spring potential energy is the oscillation energy. Are you clear with that? What is the initial spring energy? Zero. What is the maximum spring energy? Half k x max square. So where do you get all that energy from? So that is the energy which is going back into kinetic, and that is energy which is going back into the spring, isn't it? So oscillation energy is nothing but half mu v relative square. So A and D answer is same. But just because I use the word energy of oscillation, people are clueless. Clear with this? So when you kick that block, see, that is the reason. Did you observe? The entire system will never come to rest, isn't it? Because if the whole system comes to rest, then momentum won't be conserved. So there is always some part of the energy which is stuck. You can't recover that energy. You can't take that energy into transform. And what about the oscillations? Go and stand on the center of mass. If you go and stand on the center of mass, right, center of mass will think this guy is oscillating with what speed? What is the center of mass speed? The velocity of center of mass will be 2m 2u minus mu by 3m, that is 4 minus 1 by 3 u backward. Velocity of center of mass is u backward. This is 2u and this is u. So if you ask center of mass, boss, what are these two blocks doing? The person on the center of mass will think this guy is coming with u and this guy is coming with 2u. Agreed? And center of mass will think, okay, so I am the fixed point. So center of mass ka frame, it simply looks like one block and a spring, and one block and a spring, isn't it? So this guy is the maximum speed in the center of mass frame. Are you sure? And center of mass is an inertial frame, no? Center of mass is going with constant velocity. And what is the maximum speed? Amplitude into omega. What is this thing then? A1 into omega. There, you get two different amplitudes. And what is omega? 2 pi by time period. What is time period? 2 pi by root over mu by k. Are you sure? So find the maximum speed in the center of mass frame. So center of mass is the one who will think both are oscillating in an SHM. In the ground frame, they're not an SHM. They're doing something weird. They're doing an SHM and they're also doing a translation. Clear with that. Only center of mass will think they're in pure oscillation, pure SHM. I hope you can see how the question is. It's like you didn't do anything different, isn't it? You did everything with A and B only. But that C and D questions will make it really tough. So it's a good one. It's a pretty good problem. It's SHM, momentum, and energy. I hope you guys remember this question. Man walking on a plank. Let's get these two. Standard result, first one. Second is a variation. So there are two people, A and B, they walk towards each other, plank of length. They'll find the displacement of the plank. Yeah, that's a standard one. Let's see. Yeah, these are the standard results. So I'll just show you the second one though. So what is the catch in this thing? When they're moving, right? Since the forces are internal, the center of mass will not move. So this is how you do. Let the plank go by x. Choose any direction you want, doesn't matter. Then B will come here. A will come here. So the plank moved x backward. How much did A actually walk? Even though it looks like L, he actually walked L minus x. And how much did B walk? B actually walked L plus x. So displacement of A is L minus xi cap. Displacement of B is minus of L plus xi cap. And displacement of the plank is minus xi cap. Since the center of mass of the system is not moving, delta x center of mass must be 0. So that means mass of A, delta x of A, plus mass of B, delta x of B, plus mass of C, delta x of plank must be 0. Equations will get the answer. Clear with this? So you can use that same formula there for the displacement and you can finish it off. Any doubts on this? Now in this question, right, there are a lot of variations. Look at this thing. The question will be asked like this. They will say there is a balloon here and there is a monkey which is climbing the balloon. As the monkey climbs the balloon, balloon comes down. Find the displacement of the balloon. Now the question looks different, but if you actually think about this, balloon is nothing but the plank and the monkey is nothing but the man walking on a plank. You get the same answer, ml by m plus n. Another way of asking, there is a wedge here with a circular thing. Find the displacement of the wedge when it comes to the lowest position. Now we are only interested in the horizontal displacement. Wedge will only go left and right. Means vertical, I don't care. So you can simply replace this whole problem with a plank of length r. The ball becomes the man and the wedge becomes capital M. Are you clear with this? Suppose if the ball goes to the other side, then the length of the plank becomes 2r. Sure? You can even play more variations with this. They will say this is M, there is a block of mass M and length L. Same question, find the displacement of the wedge, all surfaces are smooth. Find the displacement of the wedge when the block comes down. Since the wedge only goes left and right, we actually don't care about the vertical thing. So when the block comes here, so the wedge has gone backward x. This thing is gone L minus x. Same story, you'll get x is equal to ml by m plus n. So understand, you're not doing a different question, only the way they ask keeps changing. You can even play like this. They will say there is a ring here of mass m. There is a ball here of mass m, length L. Find the displacement of the ring when the ball m makes an angle theta. Find the displacement of the ring. Can you find this? That's a good one. Find the displacement of the ring when the ball makes an angle theta with the horizontal. Yeah, you can say that. Ring is the man, ball is the man. You can take anyone, however you want. How will you do this thing? So what is actual displacement though? Initially, the distance between them was L. Finally, the distance between them was L cos theta. So the displacement is actually how much? So this question becomes like So the plank is m, this guy is small m, and this distance is L minus L cos theta, na? You're getting it? When the man walks to the other end of the plank, how much did the total distance, relative distance moved? Relative distance is L. The initially distance between the ring and the mass is L, final distance is L cos theta. So how much did they both together move? They both together moved L minus L cos theta, isn't it? So x is equal to m into L minus L cos theta by m plus m. Sure, everyone? Makes sense. You're interested in not the distance between them, you're interested in how much did they actually move together. In all these cases, horizontally, they moved L distance. Clear? Think about that once. Then this I hope you remember, standard question. Bomb explodes into three pieces, one piece retraces, one piece goes up with speed u, find the position of the third piece. And if you remember, there is a very easier case. If all the particles land on the ground at the same time, then that is the most easiest question to do. You can, the center mass will still fall at r comma 0. But even if one particle reaches the ground first, you can't use this method. Because the moment you hit the ground, there's an external force on the system, so the center mass will not continue in the same path anymore. How to do this thing? Let's see. So when this particle is actually coming, this will have a momentum of u cos theta. After exploding, they all are going with speed u. This guy goes with u, this guy goes with u, and two pieces are going up and down. One will retrace. Okay, sorry, one will retrace. So if you're retracing, you're going back with u cos theta. The other guy is going with u. So conservation of momentum, mu cos theta I cap. That would be minus m by 3 u cos theta I cap. This is the guy who retraced. M by 3 u j cap. This guy went up, and the other guy, we have no idea what he's doing. So when you solve this, you'll get two components here. So Vx, Vy. So this particle m by 3 will have a speed Vx and Vy. And this is the height of a building, which is Hmax. The question has become a kinematics problem. How do you find the time of flight? Minus, so we use this equation, Sy is equal to uyt plus half ayt square. So minus Hmax, uy will be the vertical velocity, whatever I got here, minus half gt square. You get a quadratic. So all this will get time of flight, and the range will be the horizontal velocity into time of flight. Sure. But if the particles land on the ground at the same time, that is the easiest question. Like, for example, a simpler version is this. It explodes into two pieces. One piece will retrace, one piece will go front. Find where the second piece lands. Since both land at the ground at the same time, you can argue like this. One piece retraced, so that came to 0, 0. The center of mass will continue in the same path and will land at r, 0. The other piece will land somewhere here, x, 0. Since the masses are equal, the center of mass of these two must be at r, 0. So this must be 2r, 0. Remember that method? That was the easiest one. So no, the answer is not r by 2. It is r by 2 plus this extra range, whichever you calculated. Play with this. If they don't land on the ground at the same time, you don't have an option. You have to go through this. This we already did. Let's get this thing. Two particles are projected. Find the maximum height of center of mass and find velocity of center of mass at time t. How to do this thing? Now, be careful. Meaning, could be a mistake. Generally, people think when this goes to Hmax and when this goes to Hmax, then it will be the Hmax. Not true. There's no guarantee both of them will reach their Hmax at the same time. So resolve the velocities into components. 20, 20. This is 25 cos 53, which is 3 by 5. That's 15, and this is 20. Right? Sine 53 is 4 by 5. Done. So what is the velocity of center of mass? The U center of mass will be 2m 20 I cap 20 j cap plus 25. This is mass m minus 15 I cap plus 20 j cap by 3m. So add up all the I caps. 20, 20, 40, 40 minus 15. 25 by 3 I cap, 22, that is 40, 60 by 3, 20 j cap. This is your ux and this is your uy. You want hmax, it depends only on the vertical component, which is ui square by 2g. You want velocity of center of mass? Velocity of center of mass will be initial velocity of center of mass plus acceleration of center of mass into time. Acceleration of center of mass is minus 10 j cap. Just substitute there and finish it off. Clear about that. You can just do v is equal to u plus 80 and you're done. All clear? There, let's finish off with this. A man jumps with speed u relative to the plank. Find the speed of the plank. A cannonball is fired with speed u relative to the plank. Find the range, recoil velocity of the plank. If I don't say anything in the ground frame. Let's finish off with this last one Friday. Let's see. So this kind of questions, the main thing is this: the person is not actually jumping with you. You related to the plank. The moment he tries to jump, the plank is already going back with V. So your foot is going back with V, and you're jumping forward with you. So initial momentum is zero. This is m into u minus v minus mv. So we get v is equal to mu by m plus n. Same thing here. When this thing is fired, the plank goes back with v. And this cannonball vertical component will be u sine theta, but your horizontal velocity becomes u cos theta minus v. So when you conserve momentum, you conserve for that u cos theta minus v and minus mv. We get v is equal to mu cos theta by m plus n. Your time of flight will depend only on the vertical component to u sine theta by g. Therefore, range will be your horizontal velocity, which is u cos theta minus v into time of flight. Check. Clear with that? We can do this thing also. Let's finish up with this. Last one. Collision. So there's a wall which is going with speed v, ball is going with you and hitting the wall. Find the velocity after collision. 3m and m head-on collision. Find the velocities. EC is the standard result. So how do you do the first one? You can just use restitution. So remember, after the collision gets over, the wall continues with speed v, and this guy goes with v dash. So define who is your u1 and u2. So this is your u1, and that is your u2. So this is your u1. This is your v1, which is minus vi cap. This is your v2, which is minus v, and this is your u2, which is also minus v. Signs are important. E is equal to v2 bar minus v1 bar by u1 bar minus u2 bar. So v2 is minus v, v1 is minus of minus v dash by u1 is plus u minus of minus v. So v dash will be u plus v into e times plus v. You know what's the faster way to remember? Stop the ball. Then you think the ball is coming with u plus v. If you hit a wall with u plus v, it'll bounce back with e times u plus v. But this is with respect to the wall. Add the wall ka velocity back. That's faster. Matlab signs and all, you don't want to get confused. I would have done that. You know how to do this thing. I will leave the steps here. So after this thing, this is 3m. This is v1. This is m. This is v2. Conservation of momentum, quotient restitution. What is this speed? The horizontal component will not change. That will be u sine theta, and the vertical component becomes u cos theta. This angle is phi. Tan phi will be 1 by e tan theta. Speed will be u into root over e square cos square theta plus sine square theta. Clear with this? There, that's a bit about momentum collisions and stuff. So Monday when we catch up, we'll continue from here. We will do maybe a few more problems on this work power energy, center mass, and then more of rotational mechanics. And then Monday we'll also have a speed test. Okay, with that we'll wrap up for the day, right? Please make sure to go through this revision notes also. Maybe once in a week you can just take out and randomly, not, you can see if you don't think you have time, maybe do something like 20 questions. Just flip any page and do a question. So that would help. Okay, with that we'll wrap up for the day. So any notes in the class notes, anything else you can stay back and ask, or else you're free to leave. I'll see you guys on Monday at 6 o'clock. So take care, stay safe.